All right, let's go ahead and finish chapter 5. This last section deals with solving logarithmic and exponential functions. We first have to talk about a couple of properties. The first one is the base exponent property. That says this. If you have two bases that are the same, for this case, remember, it has to be greater than 0, and it can't be equal to 1. If you have two bases that are the same, then whatever exponents you make them must be equal. So if that's true, and you raise those to the power, then that must be true. That's the first one. The second is the property logarithmic equality. What that says is if I have two logarithmic equations that are equal, they're the same base, so if that's true, the only way that's possible is if the operations themselves are equal. So those are two properties that we have to know. Yes, because if it equals 1, then it's always going to be 1. So, and if it's negative, it's going to change. It's going to be positive. If it's even, it's going to be negative if it's odd. So that's why. Let's look at our examples. So example 1. 2 to the power 3x minus 7 equals 32. We can't do anything right now because, well, we can, but not just yet. We'll use the properties that we're looking at. What the first thing you want to try is try to make them both into the same base. 32 is 6 times 4. No, 16. That's not, no, it is 16 times 2. 16 is made up of 4 times 4. There, so we know that 32 is 1, 2, 3, 4, 5, is 2 to the 5th. Since the bases are the same, the only way this could be equal is if the exponents are equal. And we just solve for x there. Add 7 to both sides. And then divide by 3. X is equal to 4. And get used to always checking your answer. 2 to 3x minus 7. Or that equals 2 to the 5th. We're saying that x is 4. 3 times 4 minus 7. Three times 4 is 12. 12 minus 7 is 5. So it works. So x minus 4 is our solution. So your first plan of action is try to get the same basis. And then compare the exponents. Now, if it's not possible to get the same bases, then we use the property of logarithmic equality. Example 2 will show this. So 3 to the power x equals 20. Since there's no way for that to be true, what we have to do then is get the x down using logarithms. Take both sides to the same log. Either log base, a natural log or a common log. Either log base 10 or log base e. So here, take the log of both sides. By using the properties of logs, the x comes down. So that x is now an exponent, a coefficient. And then divide both sides by the same log. So in this case, we get rid of log 3. We divide log of 3 to both sides. And there's your answer. Look at example 3. So 100 e to the power 0.08 t equals 2,500. Of course, the process here says we have to isolate the exponential equation. So we have to get rid of 100 from both sides. So we divide 100 from both sides. That gives us e to the power 0.08 t. Zeros cancel, gives us 25. Since the base is e, we can use ln of both sides. So the exponent goes out in front. Because remember, ln is already log base e. So since the base of this one and the operation are the same, that equals 1. So 0.08 t equals ln of 25. Isolate your t, divide both sides by 0.08. And that's your answer. Of course, type it in your calculator, you get a number. Example 4 shows us what if you have two separate bases in your initial equation. 4x plus 3 equals 3 negative x. So again, since you have different bases, you can either choose log or ln. Let's use log. Take the log of both sides. Power to a product. So the power goes down in front. So we have x plus 3 times log of 4 negative x log of 3. Change the signs. Divide both sides by x. Then divide, because you have to get the x's to one side, non-x's to the other side. Then divide both sides by log of 4. You're solving for x. So now you have to get x by itself. Distribute the negative sign to get negative x minus 3. And since it's a monomial on the bottom, so this one could go underneath both of them. Negative x over x is negative 1. Minus 3 over x equals log 3 over log 4. Add 1 to both sides. Now, since you're adding 1, that means it's going to be the same because you have to have a common denominator. It's going to be the same as log 4 over log 4. Because we need a common denominator. So on top, we have log 3 plus log 4 over log 4. Since we're solving for x, what we could do here is because this is a negative 3 over x or equals that, we can, well, let's change the signs first. Let's change all these signs. So we have positive 3 over x, negative log 3 minus log 4 over log 4. we can flip both of these to get x on top. So that gives us x over 3 log 4 negative log 3 minus log 4. Multiply both sides by 3. So it's 3 log 4 over negative. Now on the bottom, we can start simplifying all these things as well. Well, first off, you have this is a coefficient, which becomes an exponent. Log 4 to the power 3. Both of these negative signs can come out in front. It makes it a plus. Four to the third is 64. Since they're added, I can multiply them together. Negative log 12. Only thing left we can do is bring the negative up on top. So log 64 over log 12. Okay, now there's another way we could have done it. That's just one way. As long as you follow the rules, another way. We have 4x plus 3 equals 3 negative x. Do the same thing, take the log of both sides. The exponents come down. Now we could have done instead of what we did earlier, we could have distributed. We could have gotten rid of the parentheses there. Because remember, there's a minus x there. Because now what we want to do, we want to have x's to one side, non-x's to the other. So we can add x log 3 to both sides. And since this is a constant, we can subtract 3 log 4 from both sides. So on the left, we have x log 4 plus x log 3 equals negative 3 log 4. On the left side, since they both have x's in common, we can factor out the x. And divide both sides by log 4 plus log 3. So we have negative, this is a coefficient, so it goes up on top, log 4 to the power 3. Since these are added, I could multiply them together. 4 times 3, which gives us our same answer. Log of 64 over log of 12. So again, it shows you as long as you follow the rules, you get the same answer. One method can take you longer than the other, but it's going to give you the same answer either way. That was example 4. Example 5. Solve e to the x plus e to the negative x minus 6 equals 0. So what that looks like, a negative exponent simply means change the location of it. So this one is really 1 over e. It's e. E to the power x minus 6 equals 0. Because we have an e on the bottom, if we multiply e to the x to both sides, that'll get rid of our fraction. We'll have e to the x times e to the x plus e to the x times 1 over e to the x minus 6 e to the x. 0 times anything is 0. Since the bases are the same, we add the exponents. So that first part gives us e to the 2x. The x's in the middle cancel out, so we have minus 1 or plus 1. And then minus 6 e to the x. Rearranging these things from the highest to lowest exponents, we get e to the 2x minus 6e to the x plus 1 equals 0. And we see that this is a quadratic type of equation because the middle exponent times 2 gives us the first exponent. So there's quadratic. So we can use the quadratic formula. A is the coefficient of the first term, which is 1. B is -6, and C is +1. Remember, you're always solving for the middle term, whatever's after the constant there. So our quadratic equation is solving for e to the x. Is negative b plus or minus b squared minus 4ac over 2a. So plug things in there. So we have minus of a -6 plus or minus -6 squared minus 4 times 1 times 1 over 2 times 1. Negative, negative makes it a positive. -6 squared is 36 minus 4 over 2. -36 minus 4 is 32. And 32 is made up of 16 times 2, 4 times 4. So it's made up of 6. There are 1, 2, 3, 4, 5 2s. And we can bring them out in pairs. There's 1, 2. There's another 2. And the last 2 stays in there. We have 6 plus or minus 4 radical 2 over 2. On top, since they're both a factor of 2, we can take out a 2. So we get 3 plus or minus 2 radical 2 over 2. So that gives us e to the power x equals 3 plus or minus 2 radical 2. For which one? A is 1, because that's the coefficient of the first term. E is the base. The base is E. Coefficient is 1. Because we're solving for e to the x. So that's e to the x. E to the x squared is e to the power 2x. So that is e to the x squared.
So
It's part of the equation, yeah. Yes. Okay, now to solve for x, since we have a base e, we take ln to both sides. Yeah, I'll redo that. I'll show you how that really works in a second. So I have ln e to the power x equals ln 3 plus or minus 2 radical 2. The exponent comes out in front. Log ln, or log base e of e, is 1. So x is equal to the ln of 3 plus 2 radical 2, and x equals ln 3 minus 2 radical 2. Those are my two answers. Okay, to answer your question earlier, where we had to solve this is by substitution. What was that equation? We were down to e to the power 2x minus 6 e to the power x plus 1 equals 0. Since we're solving for this, we could say that u is equal to e to the power x. So we have here, we would have u squared minus 6u plus 1. Because that 2 becomes power. Because there's the rule that says if you have two bases, or if you have a base and a power to a power, you multiply the exponents. Since they're multiplied, I can go backwards. Since they're multiplied, I can make it a power to a power. E2x is the same as EX squared, which makes it U squared. Now it's quadratic. Coefficients 1, -6, and 1. So yeah, with practice, you'll start seeing that. And then we use A is 1, B is -6, C is 1. And this, since that's our middle term, we would be solving for U. We would be solving for U. Because we always solve for whatever the middle term is. Not the coefficient, but the term. After we finish this, we would get U equals 3 plus or minus 2 radical 2. U is e to the x. To get rid of the e, we take the ln of both sides. Which that's what we just did last time. It would give us ln e to the x equals ln 3 plus or minus 2 radical 2. So either way works. If you want to use substitution, you can do that. Or if you see automatically that we always solve for the middle term, that's the term. That would be 3x to the power 2.
But with e to the x, did it equal 3 plus or minus 2? Or 3 plus or minus the square root?
Because once we got the ln of both sides, the coefficient came out and the ln on this side cancels. So we get x equals ln of the 3 plus and the x equals 3 minus. We'd have to take them both, one of each.
Because for the answer to the quadratic equation, we got 3 plus or minus the square root.
Right. Yes, that's what you had there. This is the end of quadratic equation.
But would you take the 2 out of the equation?
No, because it used to be 6 plus or minus 4 square root of 2 over 2. We factor out a 2, since they both have a 2 in common. And that's why that and that cancel. We have 3 plus or minus 2 radical 2.
Because it would be 32 back to the equation.
No, the 32 became 2 to the 5th. The 32 became 2 times 2 times 2 times 2 times 2. Since we need a pair of, here's a pair, so that comes out. Here's a pair, it comes out. So we only have one more left inside there. 2 times 2 is 4, radical 2. Now we're going to end up the section dealing with solving logarithmic equations. Solve the log base 3 of x equals negative 2. There are a couple of ways we can solve. Ways to solve this equation. So we're log base 3 of x equals negative 2. Log base 3 of x equals negative 2. One way is convert to exponential. The way we do that, since it's log on one side and number on the other side, take the base, make it the base on the other side. The log drops off, it equals 8. I mean, equals x, I mean, whatever x is there. 3 to the power negative, no, so we have x equals 3 to the power negative 2. Negative 2 simply means we change the location of it. So x is equal to 1/9. Or the other method, use the properties of logs. Since the left side is log base 3 of x, if I make the base of both sides 3 and make both of these exponents, then this was using the property of logarithmic equality. So if those are equal, and if I make them both exponents, it's the same base, the exponents have to be equal. Since these are the bases are the same, the left side equals x, the right side equals 1/3 squared, which is 1/9. So it doesn't matter which way you use, you always get the same answer. Right. Let's look at example 7. Solve the log of x plus the log of x plus 3 equals 1. So using the properties of logs, we get this. We get log of x plus log of x plus 3. Since they're both the same base, they're both base 10, they're common logs, we can combine these two as x times x plus 3. This is a log base 10 of x plus 3. So once you have a log on one side and number on the other side, we could convert it to exponentials. So the base goes to the other side, log drops off, x plus 3 equals 10 to the power 1. Get rid of the parentheses. We got x squared plus 3x equals 10. It's quadratic, so set it equal to, since this is a quadratic equation, it needs to be equal to 0. So we subtract 10 from both sides. And solve by factoring quadratic equation or complete the square. X and X, second sign's a minus, so they're opposite signs. And the bigger number gets the first sign. So what times what equals 10? When we subtract them, we get 3. Five and 2. 5 gets the first one. The plus, 2 gets the minus. Now solve. We get x plus 5 equals 0. X minus 2 equals 0. X equals -5. And x equals 2. But you're not done. Always check your answer. So we have log x plus log x plus 3 equals 1. Log x plus log x plus 3 equals 1. This is x equals -5 and x equals +2. So log -5 plus log of -5 plus 3 equals 1. Log of 2 plus log of 2 plus 3 equals 1. We see the left side, the -5 cannot work because you cannot take the log of a negative number. So we cannot have a -5. On the right-hand side, we have log 2 plus log 5 equals 1. Log base 10 of 2 times 5 is log base 10 of 10. It equals to 1, so it works. So the only answer we have is x equals +2. Let's look at example 8. Solve log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. So how would you go about solving this? So using the quotient rule of logs, we get, since it's minus, it becomes log base 3 of 2x minus 1 over x minus 4 equals 2. ln x minus ln y gives us ln x over y. Convert to exponential. The base comes over there, so the log drops off. 2x minus 1, x minus 4 equals 3 to the power 2. Whenever you have fraction and equal signs, multiply by the LCD to get rid of the fractions. Multiply both sides by the denominator. Two x minus 1 equals 9 x minus 4. And then solve. 2x minus 1, 9x minus 36. Move the smaller x to the larger x. 9 minus 2 is 7. And then move the non-x to the other side. Thirty-six minus 1 is 35. Divide both sides by 7. 35 divided by 7 is 5. But we're not done. Always check your answer. Check your answer for x equals 5. We had the original equation, log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. log base 3 of 2 times 5 minus 1. Log base 3 of 5 minus 4. And minus 1. Log base 3 of 9. Log base 3 of 1. We know that log base of anything of 1 is equal to 0. So we have log base 3 of 9 is equal to 2. 9 is equal to 3 squared. So x equals 5 is a solution. And the last one. So ln 4x minus 6 minus ln x plus 5 is equal to ln x. Right, same as the last one, since it's a minus sign the same basis, we could combine those two on the left side as ln of 4x minus 6 divided by x plus 5 equals ln x. By the property of logarithmic equality, since they're both ln's are on both sides, that means the only way they can be equal is if 4x minus 6 over x plus 5 equals x. So we just solve for x. So this is by the property of logarithmic equality. Ln m equals ln n, then m equals n. So multiply both sides by the denominator, x plus 5 gives us 4x minus 6 equals x plus 5. Distribute, we get x squared plus 5x. Since it's quadratic, has to be equal to 0. Since it's a quadratic equation, must be equal to 0. So we subtract 4x from both sides, and we add 6. 5 minus 4 is positive 1. Okay, we can't factor it because since that's a plus, they both have to be the same. What times what is 6? When you add them, you get 1. Doesn't exist. Use the quadratic formula. So x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. A is equal to 1, b is equal to 1, c is equal to 6. Negative 1 plus or minus 1 squared minus 4 times 1 times 6 over 2 times 1. Negative 1 plus or minus 1 minus 24 over 2. Negative 1 plus or minus negative 23 over 2. So that makes x negative 1 plus or minus I square root of 23 over 2. No real solutions. And that's it for that, chapter 5. End of chapter 5.